Hello info person, this is Anton, and in this video we're going to be discussing an exciting possibility in regards to the origins of life on planet Earth. And that's because for many years researchers have always assumed that life started from some kind of a primordial soup, very likely somewhere in the deep ocean 4.3 billion years ago. And though at first this was just a bunch of RNA molecules interacting and creating something more and more complex, eventually this could have given birth to some of the first cells, which then started to evolve and become more and more complex. But what if this wasn't actually the case? Or at least, what if it wasn't the case in terms of the timeline and in terms of the actual location? And so what if life didn't start here, but is actually some kind of a planet hopper, moving from one world, from a planet or from a moon, to a new one through various asteroid collisions? And that's essentially the core principle of the idea referred to as the Panspermia hypothesis. The idea that life can easily spread between planets and between moons through various asteroid collisions. And well, thanks to this very recent study from March of 2026, and the study that we're going to be discussing right now, we now have some of the strongest evidence that this is not just science fiction, and in theory, could happen. But before we discuss the study, let's briefly define panspermia, just so that there are no misconceptions, and just so that we're all on the same page. And so this word, panspermia, is from the ancient Greek, and it means all seeds. It's the idea that life, usually in the form of some kind of a hardy microorganism, is distributed through the universe by cosmic dust, asteroids, and comets. And while based on a lot of propositions and decades of research, different scientists try to pursue different types of panspermia in order to determine if it could actually happen, or if it's more or less impossible because of how hostile outer space usually is. And so here we have several varieties. For example, radiopanspermia is the idea that microscopic life is pushed through space by light pressure from stars. And that's essentially how, in theory, it could move from one star system to another without the use of actual spaceships, just by hitching a ride in some kind of an interstellar comet. Like, for example, the one we've been discussing a lot in the last few months, the 3I Atlas. Then we have something a little bit more controversial, directed panspermia. The idea that life could have been deliberately sent to Earth, and of course other planets, by some kind of an intelligent civilization. Now, this by itself is not something that has any evidence, but in some sense, some scientists have actually tried to approach this from a different side. What if we start this directed panspermia and basically start sending out different rocks and different material filled with microorganisms from planet Earth? And the point here is to have them reach some other object and eventually colonize it in millions or possibly even billions of years. You can learn about this concept in one of the videos in the description, but this is basically probably the most hypothetical and not as widely accepted idea because it doesn't really have any scientific evidence. But one of the more exciting concepts in panspermia is actually referred to as lithopanspermia. This is something you can learn more about in one of the older studies from 2013, and the point here is pretty easy. It essentially suggests that microbes and viruses can easily hitch rides inside various rocks, using them as a kind of an asteroid taxi. And so basically, as an asteroid is blasted from the surface of the planet, usually because of some kind of a collision with something else, it can then transfer material from one planet to the other planet, especially if those planets are pretty close. And that's actually what's been happening to both Mars and Earth for billions of years. We find a lot of different rocks from Mars right here on the surface, and we're pretty certain that Mars contains a lot of different rocks coming from Earth. We just haven't really been to Mars yet to confirm this idea. And so in this very recent study, here this is actually what makes all of this kind of a big deal. This new study from the Johns Hopkins University basically did this. And that's because scientists wanted to find out if microbes could actually survive the violent moments of ejection or the violent moments of crash. In other words, since they basically have to survive two separate impacts, the one that creates the asteroid and the one that causes the asteroid to crash, is there any chance that anything from Earth could survive this if we simulate the collision by using laboratory equipment? And so here they used a specialized gas gun to fire projectiles at a very famous bacterium referred to as Deinococcus radiodurans, something we've discussed in some of the previous videos, and the bacterium that's also known as Conan the bacterium, one of the strongest extremophiles found on Earth, known for able to survive extreme cold, radiation, dryness, and even outer space. We'll come back to this in a few seconds. And so here the team sandwiched these microbes between various metal plates and then subjected them to massive transient pressures of up to 2.4 gigapascal. And that's about 10 times the pressure found at the bottom of the Mariana Trench, the deepest point on planet Earth. But at the same time, this is the kind of pressure we actually do expect from a typical asteroid collision that's able to launch various rocks or various debris from our own planet. And so that's basically what this experiment was trying to recreate. And the surprise here was that a lot of the bacteria survived. For example, at 1.4 gigapascal, nearly 95% of them were able to survive without issues. And as you can see from this graph, compared to other bacteria, Conanobacterium was definitely extremely resilient. But surprisingly, even at 2.4 gigapascal, at least 60% of them were able to survive as well. As a matter of fact, here, the steel equipment actually broke, while the bacteria was able to survive. Once again, that's what you're seeing in this video right here. And though this graph shows us that some other bacteria only survive in extremely small numbers, for example the famous E. coli, this experiment definitively shows that there are some extremophiles that can survive direct impacts, and thus in theory could be launched to other planets and to other moons. Here we actually even have pictures of the before and after. And so in theory, quite a few of these asteroids containing Earth bacteria could have already escaped to outer space and possibly land on other planets and other moons. As a matter of fact, at least 105 meteorites that have been confirmed on Earth definitively came from Mars. And that's because large asteroids hitting Mars very likely ejected rock fragments at high velocities, which then landed on Earth. And so in a different study from the Penn State University, computer simulations were able to track where some of these rocks would end up, discovering that over billions of years, tens of thousands of rock fragments from Earth and Mars, even reaching as far as Jupiter and Saturn, or basically reaching their moons and possibly implanting them with some of the ancient bacteria that existed on our planet. As a matter of fact, the study estimated that at least 6 rock fragments from Earth definitively landed on Europa over the last 3.5 billion years. Which means that if we do find life on Europa or Enceladus, there's actually a somewhat high chance that this alien life is not so alien after all. Instead, it might have come from our own planet and eventually evolved somewhere else. But here there's, I guess, one more question we need to tackle. What about the radiation in space and a lot of other hostile conditions such as the vacuum itself? And surprisingly, this is something that has been extensively tested by Japan between 2015 and 2018. Here this is the famous Japanese Tanpopo mission, part of the International Space Station. You can learn more about this mission in one of the videos in the description, but here once again, Deinococcus bacteria, or Conanobacteria, were placed outside the station, exposing them to vacuum and extreme temperature swings, as well as high UV radiation in outer space. But surprisingly, when the samples were collected 3 years later, scientists discovered that a lot of them did survive and were able to function normally. And here this actually included 3 separate bacteria, yeast, and even other microbes, all of which were able to survive harsh environment of outer space. With the overall conclusion from a lot of these studies suggesting that if these bacteria or this yeast can actually form different clumps or can somehow tuck inside the rock for shielding, they can actually survive potentially indefinitely, until they reach a new location where the conditions are much more hospitable. Now here scientists don't actually know exactly how long they could survive, but the estimate suggests that they should still be fine even after several decades. And while this of course has a lot of implications for a lot of different biological fields, but even for some of the modern missions that have already been launched and have landed on other objects. For example, there have been successful landings on Mars and even Titan, and based on some of the previous studies we know that NASA's clean rooms turn out to be not 100% effective. Some bacteria can still survive and thus hitch a ride on various probes and then end up on other objects. And so for all we know, all of these probes will send to Mars, or all of the future probes will be sent into Europa and Enceladus, may actually accidentally seed them with life from Earth. Now the chance of this happening is still pretty low, but it's nevertheless there. Likewise, a lot of asteroids and meteoroids already traveling between planets somewhere in outer space could in theory contain ancient life that's in some kind of a dormant state. And so by capturing one of these rocks sometimes in the future and discovering where it potentially came from, researchers might be able to get some additional clues and possibly figure out if panspermia is something that's happening in real time even right now. But at least based on these recent discoveries, what we can definitely say is that lethal panspermia, or basically surviving these massive impacts in order to escape the planet and to then land somewhere else, seems to be much easier for life than we previously thought. or at least some life, that's already established itself in some of the most extreme conditions on the planet. And while we don't have the direct proof for life arriving from somewhere else or going somewhere else yet, at least now we know that it's definitely physically possible. Which of course means that there is now a slight chance that we might be Martians after all, or maybe other moons and other planets contain a lot of our cousins that evolved in their own ways for billions and billions of years. And that's of course one of the main premises in astrobiology and why it's such an exciting topic. For all we know, the entire solar system may be teeming with life that possibly started with one single source. But what exactly the source is currently unknown. Which means that we'll come back and discuss all of this in some of the future videos once there's some additional research. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.